April 24th meeting of the Water Quality Committee is in order. Steve Rafferty apologizes that he couldn't make it, so you have to put up with me. The first item on the agenda is Paul Dombrowski. We're going to talk on denitrifying permeable reactive barriers. His group worked with Matt Charette in our project on Shorewood Drive, and he's going to talk about a larger scale.
Okay, good afternoon, and thank you to the committee for having me and your support of water quality and PRB, and particularly the project on Shorewood Drive. Definitely an interesting project. We got to learn more and advance our understanding about PRBs and denitrification with that project. I'd also like just to acknowledge Tim Pack, who's a geologist with Terra Systems, who is here and has been, Terra Systems is also part of the PRB team on Shorewood Drive as the emulsified vegetable oil manufacturer. So Tim supported this presentation, is here today also to answer any questions. Just really an overview, a little bit about me, a little bit about IceTech and my company. So I'm an environmental engineer. I spent about 12 and a half years in consulting, including at AECOM, designing the Orleans demonstration test. So that was, and I've been at IceTech for almost 7 years. And so we are a soil and groundwater remediation company, and we focus on treatment of various contaminants in the soil and groundwater, primarily in situ. And we work on projects all over the country. In the last 5 years, we've been in about 25 states and Ontario. And then Terra Systems is a bioremediation technology manufacturing firm. They were involved in the first demonstration test for anaerobic bioremediation. They have the patent for using emulsified vegetable oil for dechlorination. And are also involved in various chemical oxidant and surfactant development for creating better remediation projects. And one of the great things about them, and which we took advantage for the Shorewood Drive project, is their ability to customize their products based on the site and the geology, the contaminants, groundwater flow, and the like. So we're going to talk about denitrification PRBs. So I think some of this, just by show of hands, who's pretty familiar with denitrification? Okay, about 2/3 of the room. And so we'll just kind of very high level. I've got more slides than I think I'm going to handle, but they'll be there. We can go. So denitrification is a widely used process in conventional wastewater treatment for treating nitrate and removing nitrogen from water. These are bacteria that sequential steps convert nitrite to nitrite, eventually to nitrogen gas. These are anaerobic bacteria, meaning they operate in environments without oxygen. And these bacteria are very commonly found in soil. So for the Shorewood Drive project, we didn't add any bacteria. We just created conditions that were more conducive to their activity. And then permeable reactive barriers. There's 3 words there, and those 3 words are important. Permeable means the groundwater flows through it, so it's a passive remedy. Reactive, where we want to promote some level of treatment with inside the barrier. And then a barrier in itself, meaning where we're creating a line or a fence or a zone where, in this case, nitrate, but other groundwater contaminants will be treated within that zone and not pass to the other side. And that is the objective. So these are denitrification, permeable reactive barriers. And as we know, Cape Cod is looking for, at our various watersheds here, at reducing nitrogen loading into our surface water bodies and coastal waters, working under total maximum daily loads. And a real benefit of a PRB is that, unlike a lot of our groundwater treatment sites, we're not necessarily trying to meet a concentration objective. We're looking to reduce mass flux. So it's more a matter of, can we reduce the amount of nitrogen flowing through there, what's on the up gradient side, to the down gradient side, than saying we have to meet X milligrams per liter of nitrogen. So they can be fit, and they can also be placed to locations or depths in some places, and we saw that at Shorewood Drive as well, and I'll show that on a later slide, about where the most nitrogen is flowing through, and we can put a permeable reactive barrier there to stop the flux there. And if there's other places where maybe there's a nitrate, but not a whole lot flowing through, not a high flux, we don't necessarily need a barrier there. So we can design where we place barriers based on those nitrogen loads and nitrogen fluxes. And there's quite a few challenges of working with PRBs just in general on Cape Cod, and this whether they're injection or trenches or otherwise. But there's places where there are high nitrogen fluxes at 70 feet below ground surface, including the Orleans site where we were doing injection at 72 feet and still seeing a fairly high flux at that depth. Given the permeability of our soils here, medium to coarse sands in some places, we're seeing fast seepage velocities, some sites as high as 100 feet per year. So a pretty quick groundwater flow, which on sites where there's higher oxygen, we have aerobic water, we have higher nitrate, that means you're seeing a pretty high flux of oxygen and nitrate flowing into our reactive barriers. We have a developed region, so access working, finding places where we can put PRBs in. There's been a few locations where Kristen and I have been discussing the last, well, maybe a PRB might work here, maybe it might work there. We have to be thinking about, well, where are the homes? Where can we put monitoring wells? Are there a lot of utilities there? Is there a lot of traffic? So those are all just implementation challenges when you're looking for a larger scale PRB versus a 100-foot pilot test. There's some sites where there's low pH in the groundwater. Shorewood Drive is one of them, where we were seeing pH in the 4 to 5 range. Bacteria have ranges of pH, and below certain pHs or above certain pHs, they're not really happy, and they're not going to do the degradation that we needed. So the Shorewood Drive was one where we had to add some pH buffer to increase the pH a little bit to get the bacteria to be a little bit more active and just keeping our bacteria happy. And then just really thinking about the persistence and rejuvenation and how often do we need to go out? How long are these going to last? And these were some of the questions that were asked from some of our pilot tests that were done. And really, as I said, knowing where the flux is, then we can place the barriers accordingly. This was one of the sites that was evaluated for, I'm just going to use the pointer here, for a PRB where there was multi-level sampling. And we can see here that at a certain depth, we had significantly higher nitrate, and that's over maybe 10 or 12 feet compared to the nitrate above or below it. And you can see here, above it, the nitrate's not 0, but it's 3 to 5 times less than it is in this other 12-foot zone. So when we're thinking about nitrogen fluxes and PRBs, we may only want to target this certain vertical zone depending on what the goals are for the TMDLs or that watershed. So just kind of a little bit about, I've talked about denitrification and permeable reactive barriers, and I've mentioned emulsified vegetable oil a little bit, but I want to just kind of step through just a quick history lesson about how did we even get here. So emulsified vegetable oil, it's really just that. It's vegetable oil, much like we would use for cooking. It's typically 60% soybean oil, so it's food grade. But we also know that oils are hydrophobic. Oils and water don't mix really well. So in this case, an emulsifier is added to make it more hydrophilic so that you can dissolve it in water, and it makes it easier to inject at your time of delivery. That emulsion breaks down over a few weeks, and then you're just left with hydrophilic oil droplets stuck in the pore spaces that then release carbon over a slow period of time, often a period of many, many years. These are widely used for biodegradation, predominantly for chlorinated solvents, the tetrachloroethylenes from dry cleaners, trichloroethylenes from degreasers. And so that's the emulsified vegetable oil that has been injected, and I'll talk about some more. And then using vegetable oil for permeable reactive barriers or any other amendment for reactive barriers are widely used for groundwater treatment, particularly for large-scale treatment areas. This is just a quick snapshot of a project that I was involved in back in 2010, 2011. And this is a snapshot taken out of a preceding paper that I wrote for a conference in 2011. This was a 6-acre VOC plume in a wetland. And so instead of gridding up and putting injection points across the entire 6 acres, we put reactive barriers that were appropriately spaced based on groundwater flow and the flux. And so this is a concept that's not new for groundwater treatment. And so some of this experience was that I was able to bring forward into our planning at Orleans. And then thinking about PRBs and denitrification, a number of bench scale tests have been performed. As I said, EVO is commonly used for bioremediation of various contaminants. PRBs have been widely used. It was like, well, how can we take the knowledge from EVO and PRBs and put it towards denitrification? It's similar, but different. So Terra Systems, Tim's organization, was involved in doing a number of column tests, including going back to 2014, 2015, doing some column tests, actually using some soil that was collected from the Shorewood Drive site. And looking about if they had water flow through at a pretty good rate, faster than we'd expect, but at some of these sites, but kind of thinking about longevity and realizing that off-the-shelf EVO was not going to last long enough. It wasn't getting the longevity that we needed for high-flow, coarse, sandy material that we have on some of these Cape Cod sites. So they went back to the drawing board and they reformulated an EVO formulation that was meant to be stickier to sand grains. And this is the EVO that has been used on the demonstration test on Cape Cod. And then when we did the Shorewood Drive pilot test, we collected more soil. They did a few more bench scale tests to kind of think about longevity, residence time, how much residence time is needed to get full denitrification in a column, which we can maybe scale up. They also did a number of studies with pH as well. And then there's been a number of other batch tests and modeling that was performed by a Tufts University graduate student, looking at actually kinetics of denitrification rates, looking at further tests on batch reactors on pH and denitrification. Where is that lower pH? Where does it stop? And it actually is about 4.9 to 5, and we were able to find that through various batch tests. And then also looking at microbial cell counts in the soil and how that may or may not affect PRB effectiveness. And I just as a quick screenshot, the cover of Veronica's master's thesis. And I and Dr. Mike Lee from Terra Systems were on her thesis committee as co-advisors. So it was neat to kind of take a step back from these larger scale PRBs and kind of look back at batch reactors. How do we better understand some of what's happening on the cellular level? And then that brings us into the 4 demonstration tests. There's been 4 pilot tests on Cape Cod and Martha's Vineyard so far. All of them use emulsified vegetable oil, and they all have 3 to 7+ years of groundwater monitoring at this point. So there was one on Martha's Vineyard. We see the R1 here in Falmouth, and then ones in East Ham and Orleans. So just kind of a little bit of how they all went. Orleans was the first one. It was first installed in November of 2016. And one of the first objectives of that was, being the first one, is how long might this last? At the time, we were thinking, all right, if we get more than 3 years of longevity, that would be a really good outcome. We did a number of studies. We kind of looked at, on the front end, put some monitoring wells in, and then we put some more monitoring wells in as we were setting up the monitoring well network, and realized we picked a location that had a really funky hydrogeology, groundwater flow. There was groundwater coming from the south, coming from the west. There was a wastewater treatment plant from the school where we're at over on the west, so there was nitrate coming from this way and coming from this way, and then there was a stormwater storage tank that was playing with. So we ended up extending the PRB and adding that north to south PRB here, just to catch some of this additional nitrate that was coming in from the west. We knew we were catching the nitrate coming from the south, but there was other nitrate from the west that was impacting some of these monitoring wells. So we wanted to make sure we definitely cut that off as well. And that follow-up and extension was done in 2018. Just kind of a picture of what this looks like. We have a small drill rig that's pushing points into the ground. They're temporary points. This dotted line is approximately the barrier, and we can see here we've got a number of injection points all happening simultaneously. And then all of the batching was just set up in a small containment pad, so a relatively small footprint when we do these injection events. So a few things we learned from Orleans. One of the things we saw is we actually didn't see a whole lot of EVO, which has a white color. We didn't see increases in turbidity at wells immediately after the injection, 6 to 10 feet away from the injection point. So we saw that as a good sign that this was the first time this stickier EVO formulation was injected at any site. And so it seemed like it was stickier. I've been involved in other off-the-shelf EVO projects where post the injection, a well 10, 12 feet away may see some of that white color. So that was a good sign. Since that time, the consultant on that project has been collecting samples for over 7 years, and they're still seeing pretty robust denitrification at those wells. So that's a really good sign with this loading, knowing if we have similar hydrogeologic conditions at a site, that we will see this continued denitrification. And then we got some sense of what the groundwater flow rates were, what the kind of the estimated flux of pound of nitrate removed per pound of EVO, and also a little bit of a sense about pound of nitrate per linear foot per year. This PRB thickness was 32 feet or so it was a larger vertical interval than we had at Shorewood Drive, but we were seeing a larger vertical zone of high nitrate at this site, so that's what this site PRB needed. And this site, this image I find is really, really telling. So here's just the darker the red, the higher the nitrate concentration, ranging anywhere from 6 up to 15, 16 milligrams per liter of nitrate. So this is pre-injection. There were more wells put in, but we can see that in this zone here, we're seeing a fair amount of nitrate, pretty dark red. And then in the same zone here, this was 2.5 years after the first injection and more than a year after the extension. And we're seeing next to non-detect concentrations of nitrate immediately down gradient. So just kind of a nice visual demonstration of that, how effective these PRBs are. So our Shorewood Drive, the other 3 PRBs were all installed within a few months of each other in 2020. And so that was all, remember, being COVID, and so there was some schedule delays just with working around that. But this one was funded partially through a SNEP grant with matching dollars from the town, so thank you for the town for that. And one of the things we thought going in is that there was some preliminary investigation at the site, and we thought the flow rate at the Shorewood Drive site was going to be faster than Orleans. It turns out it's about the same, maybe even a hair slower, but one of the things that we did within our investigation and working with the Woods Hole Oceanographic Institute was getting better hydrologic conductivity data for the site so we can get better velocity estimates for the site. As I mentioned, there were low pH, so we knew we needed to be thinking about that. And we also wanted to apply 2 different dosages. So the north half of the PRB versus the south half got 2 different dosages, and we were trying to see, because dosage is a cost factor, but could we actually see failure within that 2-year monitoring period? And so knowing if a PRB really needs a really high dosage like we applied in Orleans, or could we get away with a lower dosage? There was quite a bit of multi-level monitoring, which I'll show, which has been really useful to see, and also more monitoring of secondary groundwater parameters, metals, methane, and even Woods Hole did some additional analysis for some of the nitrogen gases, the partial denitrification products. So as I mentioned, having this vertical sampling, we were able to, at some of our wells, so this is 4 different wells, sampling at 4-foot intervals. And we can see that in 2 of the wells, that the nitrate was much higher in the shallow interval, and at the other 2 wells, we saw higher nitrate at the lower intervals. And these are wells that are even 50 to 60 feet apart. So even across a PRB, the different zones of nitrogen flux need to be kind of taken into account, and we may have even been able to adjust dosages a little bit in hindsight. But this is keeping in mind that this is not be uncommon across a PRB or the length of a PRB. So it's one of those that having more characterization can only help the design, and maybe we can, certain places go deeper, certain places go shallower, certain places maybe not as much, and try to find those optimizations and maybe even cut some cost along the way. And what we really saw is where we had EVO distribution, we saw really strong signals of denitrification. We also saw the dissolved oxygen decrease, the more reducing conditions, and we even saw the pH increase where we saw pH buffers. So that was good. There were some deeper zones. So we can see here this gray line is the baseline nitrogen, and then you can see here next to non-detect nitrate in these zones. And in this monitoring well, the multi-level, we didn't see as effective denitrification down deep. And this was at a well about 15 feet down gradient, but we didn't ever really see reducing conditions generate there. What we did see is as we got down lower, much higher pressures, much less permeable soil. So it was a little bit harder to push the EVO out in that zone. But one thing to think about is that was also a zone where there was less nitrogen flux in the first place. So it wasn't as important that we got really effective denitrification. But it was interesting to see even just how we could, there are zones that are, the top 8 feet, the middle 8 feet, and the bottom 8 feet, even within a PRB, were behaving slightly differently. So some of the lessons that we learned from that. And there's just a few other observations. We saw with the 4 PRBs, Isotech, my company, was involved in performing the injection on 2 of them, the Orleans one and the Falmouth one. Terra Systems was involved in all 4 as the EVO manufacturer, and we've been working with Terra Systems to evaluate all of these lessons learned and how do we modify. But we saw very high nitrate and very low nitrate as well. The Eastham PRB was looking at concentrations as low as 0.5 to 1 milligram per liter, maybe up to 5 milligrams per liter. That was the highest concentration they saw. Where we had some of the wells at Falmouth looking at 20 to 25 milligrams per liter. So these PRBs worked at low nitrate, they worked at high nitrate. The Martha's Vineyard test, one of the things they looked at measurements of nitrogen gas, dissolved nitrogen gas in the groundwater, and saw complete denitrification by seeing higher nitrogen readings in the groundwater down gradient. So that was also a good sense of that, and also from the measurements that the Woods Oceanographic Institute took, generally we saw low concentrations of those intermediate nitrogen gases in the groundwater as well. So, taken together, it is a good sign that we're not leaving these partial nitrogen products that are also greenhouse gases in themselves. So just kind of as a summary, we're seeing denitrification for more than 5 years. The dosage does seem to be a critical parameter. As I said, we tried 2 different dosages for the Falmouth site. The higher dosage definitely showed us more effective denitrification. 1 row versus 2 rows was tested on the different PRBs. The 2 rows seemed to show a little bit of better, whether that just prevented a little less flow through. Typically the rows would be offset. So if they were points that 10 or 12 foot spaced, the second row would be offset about 5 or 6 feet. So maybe we're just catching maybe a little more residence time. We saw limited migration of the secondary water concerns, the white color of the emulsion, the metals, and really that flow direction and velocity are really critical to design and interpretation of these PRBs. So a lot of these lessons learned from the 4 PRBs, and then a lot of the knowledge of other PRBs and using EVO. Terra Systems, Isotech, and the Woods Oceanographic Institute, as part of the Shorewood Drive SNEP grant, developed an engineering design manual for developing denitrification. So this is available on the Terra Systems technical resources page for download, and we were really happy with kind of how this came together. Took a few more months than we liked, but we really wanted to have a really solid product that we can stand behind. So that can be downloaded, or if he wants to email me or Kristen afterwards, we can send you the link as well. So kind of those are the demonstration tests, a little bit of history lesson. Where are we going from here, right? The question is, now what? How can we think about full-scale PRBs? Or how can other PRB alternatives be implemented for reaching some of our nitrate groundwater goals? So want to kind of spend a little bit of time dissecting the costs. Kristen and I talk about this pretty frequently, and about some of these metrics that we're none of these technologies are exactly apples to apples. So we try to have some kind of metric. One being $1 per pound of nitrogen removed, or maybe pound per linear foot. Thinking about, well, if we had a 1,000-foot PRB versus a 1,500-foot versus a 700-foot PRB. So, how do we think about these? How do we break these down and try to understand this? When realizing there's a whole lot of sensitivity analysis in this, so it does become a little bit of a site-specific exercise, but a few of the key sensitivity parameters, of course, nitrate, flux or nitrogen mass, if you have high concentration or low concentration, or if you have a high concentration but a really low groundwater flow, or a medium concentration with a high groundwater flow, that helps us understand how much mass is flowing through. We need to think about the soil permeability. That's going to tell us how fast groundwater might be moving, but also how easily is it to inject a fluid into the ground. How fast can we inject a fluid in the ground? Because we have a more permeable soil, we may be able to implement the PRB faster. So that's going to impact the time and materials cost. What is the vertical interval depth? Kind of showing that the shoreward drive image again. Do we need to treat 16 feet, 40 feet, 30 feet? That's going to have an implication on both the flux and how much mass we're removing, but also how much time we're out there and what are the costs to implement that. Depth is a factor. We also want to think about other electron acceptors. Is there high oxygen? Is there sulfate? And how long is this barrier? Costs generally are linear with length, but regardless, it is a piece. So I want to dissect with a little bit of sensitivity analysis the cost per pound nitrogen removed. That's one of the key metrics that we're talking a lot about. So for cost, it really is time and materials. How long does it take? How many days is the injection team out in the field? How much staff do they need, and in terms of equipment? And what are the materials? How much emulsified vegetable oil? Do you need a lot of pH buffer, a little bit of pH buffer? And those are the pieces that really drive the cost. And then the pound removed, said some of that sensitivity is with the nitrate concentration, groundwater velocity, vertical interval. So in the sensitivity analysis, I ran and I'll share, I put a range of nitrogen concentrations, 4 to 20 plus milligrams per liter. Groundwater velocities of about 40 feet per year, which is pretty slow for some of the sites we see on the Cape, up to about 180 feet per year, which is not unreasonable to some of the other sites we see. And also a vertical interval. One of the scenarios that Kristen and I were talking about a year ago, we really didn't know what the vertical interval was because we didn't have sampling. But we said, all right, let's assume 16 feet and let's assume 28 feet. Let's just to give us a range of costs. So we were looking at about 1,000-foot PRB. We assumed somewhere between 8,000 and 10,000 gallons a day. So for those scenarios, about 9 to 20 injection days. That's based on having really doubling the productivity of what we were doing during most of the pilot tests. We were doing anywhere 3,500 to 4,500 gallons a day. So this is bringing out a bit of a larger crew, more equipment, so we can do it, really double our productivity and try to minimize the time that we're in some of these areas, especially if they're roads, residential areas, and the like. And then thinking about pound nitrogen removed, it's a flux. So it's concentration versus times flow versus time. And that's where we want to think about barrier length, treatment thickness, the velocity, the nitrogen concentration, a whole bunch of things that can vary site to site, vertically. So from that, the cost for that 1,000-foot PRB, roughly we came up kind of the 600,000 to 1.2 million, about a factor of 2. A lot of that range was the vertical interval. Was it 16 feet or 28 feet was almost double that, and then kind of think if we had that slower productivity time. And we assumed 2 rows of injection points. Whether we actually went with 1 or 2, we may divide the volume into 2 rows, or we may just have we could have 1 row that has the same amount of volumes, so that may not change. And then, I looked at using our sensitivity analysis. It ended up being anywhere between about 50 and almost 1,800 pounds of nitrogen per year, depending on those sensitivity factors. If we looked at the Orleans demonstration test and looked at their concentrations and what we came up with, there we would have about 150 pounds per year if you had a 1,100-foot PRB. Assuming a 7-year lifetime, That's about 350 to 13,000 pounds of nitrogen, probably somewhere in the middle of there. But the Orleans PRB is still going after 7 years. So after that, that's all bonus. But we're seeing even within that pound of nitrogen removed and those sensitivity parameters that are not within the range of expected parameters for Cape Cod, we're still looking at a factor of 40. So that highlights the importance of PRB site characterization. It kind of gets us into that range of the really expensive side, $3,000 a pound removed. That's really high. But it could be, if you had a high flux site, it could be as low as $50 per pound of nitrogen removed. Again, if we can find out where the highest fluxes are, we can really inexpensively remove nitrogen from the ground. So that's kind of a little bit of breakdown of that sensitivity and realizing that it is site-specific, but the importance of that characterization, but then we can kind of develop these cost models relatively easily once we actually know where the nitrogen is and how fast it's moving. One of the other questions that's kind of coming up, well, what about an alternative? What about mulch borings? And so kind of did a little bit of a cost evaluation of that. What if we were to take the Shorewood Drive pilot test? 120-foot linear foot PRB, 42 feet was the depth that we generally went to, and kind of what are the pros and cons of comparing them? So for the injection for 120 foot, we had 12 injection points, and we completed the injection in 4 injection days. We had about a half day at the front end to set up, receive our chemicals, but we were off the site in less than 5 days. Similarly, if we had a 4-foot spacing on our mulch, so we kind of think about, we would do a 12 or 13-inch boring here. I know I'm off TV for a minute. And then we went over 4 feet and did it again, and then repeat. For that same 120-foot length, we would need 12 to 13 drilling days. If we wanted even closer spacing, it would be even more. So now we're on the site for that same period of time, for a longer period of time. The install cost was about the same, kind of plus or minus 10, 15%, something like that. And depending on a little bit of scenario, the mulch barrier may come in a little bit cheaper, and then the other scenario, it actually came out quite a bit more expensive, where the injection cost was kind of relatively narrow here. The plus minus bars were here for the mulch barrier. One of the nice benefits of the mulch barrier is probably a longer lifetime. You're going to put it in. It may last 10 or 15 plus years, which is great. The downside is you're going to get a smaller radius, smaller residence time, where the injection points, you're going to get a radius of influence of about 10 feet. So you're creating these 20-foot diameter circles. So as the groundwater is moving through at something, only 0.2, 0.5 feet per day, you're getting 10 days of residence time at least going through there. So you get a lot of residence time for removing nitrogen. Whereas if you have a residence time of a 12-inch boring, you're not going to get a whole lot of residence time, and you have higher likelihood of flow through. So higher potential of bypass your nitrogen. You're going to have soil cuttings that need disposal, handling. Your injection points may have a shorter lifetime, maybe 5 years, but much shorter time to install, no soil to dispose of, much larger residence time, and likely more nitrogen removal. The alternative would be to do more mulch borings, maybe put them in 2 rows, maybe 3 rows, but then to get that same residence time, you're really significantly increasing just your time on site, right? Disturbance, let alone cost. And then also the kind of questions come up about small scale PRBs. Could we install an EVO injection downgrading of a leach field? Whether it's for a home, whether it's a new condo complex that's coming in, and we might have shorter lengths, shallower vertical zone, where some of the PRBs we're putting in are 40, 70 feet down because they're picking up nitrate that was distributed to the groundwater miles away, and by the time it's kind of going in and coming down. So if you could inject in the shallow groundwater right near the septic field, shallower injections. And then the alternative to some of these advanced septic systems is no excavation on somebody's property. If it's already in, you could go in, you can put a handful of injection points in. They're 1.5 inches in diameter. You drive in, you drive out, and you're done. So just kind of thinking about a 50-foot long PRB that you put down gradient of someone's leach field or at a building, 8-foot vertical thickness, because we're kind of right in the shallow groundwater, right where it's lasting. We could do it in a day. Cost would be less than $30,000. And if maybe there were multiple homes in the same block, or even if we could go to property one on day one, go somewhere else, somewhere else in Falmouth on day two, somewhere else, and now we're kind of lumping those mobilizations into the same week, just working out of the back of a box truck, something like that. There'd be further cost savings to there, just because of efficiencies in scale and mobilization and things like that. Kind of did a quick internet search for some of these advanced treatment septic systems, costs of $15,000 to $75,000. So we're kind of in line in cost, maybe cheaper, much less disturbance. We're not digging up anybody's yard, and that cost could even be higher for a larger system. So just kind of thinking about, I hadn't really thought about this until last week about, what are these costs actually, we've kind of talked about them kind of qualitatively, but this presentation forced me to think about it more on a financial basis. So kind of PRBs can have a much smaller capital cost than sewer wastewater treatment plants. It all depends on that characterization and identifying those high flux zones. They can be a way to address particular point sources, particular properties, or a non-point source. You might be able to treat closer to a point of discharge. But also one of the things that some of the towns are thinking about are, can this be done as a temporary solution? Maybe it's going to take 30 years to get all of the sewering that's desired, just to fund it, to construct it, to design it. If you put a PRB in now and you get 7 to 10 years out of that, maybe if it takes 10 years to fund design and put you can get that nitrogen removal credit now and for the next 10 years. And then you don't necessarily have to worry about rejuvenating or re-injecting that PRB, because in 10, 15 years, maybe the sewering will be in by then. So, yeah, I think that's kind of my overview. I think there's going to be a lot of questions about how do these move forward, there's a lot of regulatory questions that are come out of it. I'm setting up a meeting with DEP for next week. They have a lot of questions from me about how do these PRB installs go, what does the data look like. I think we're all going to have questions. If you have any questions you want to share with me that I can ask DEP about monitoring, about how are they going to think about permitting that. Those are some of the things that they're also curious to hear. What are the towns asking about these PRBs and things like that. And as we know with a lot of things, I think microbial assessments are going to be a valuable tool. And some of the commercial labs are starting to evaluate having denitrification functional genes and biological targets to better understand if there are certain sites that maybe there's higher concentrations of denitrifying bacteria already present, where some we may have high flux but maybe not bacteria, so then maybe we should be thinking about maybe bioaugmentation, which is actually injecting denitrifying bacteria, which you can buy off the shelf for wastewater treatment plants, maybe for that small cost, or maybe there's certain sites that have a lot of native denitrifying bacteria and some sites that have less, and so those assessments will tell us a little bit more about how we can optimize our PRBs as well. So I really thank you for having me come down. I thank you for your interest in PRBs and looking at other methods of removing nitrogen from groundwater, protecting our watersheds.
Thank you, Paul. I'm going to take questions first from the committee, starting on the left.
I guess I'm curious. So I know we're talking mostly about leaching fields and septic or originating nitrate.
Sure.
But I'm working on a project. I work for the APCC, the Association to Preserve Cape Cod, and we're looking at possibly using PRBs for treating stormwater from like catch basins that are like leaching catch basins. And I guess I'm just curious about your thoughts on if that's an effective way to be treating, groundwater, and if we should be focusing at all on sort of that stormwater angle.
So this is a catch basin that's collecting stormwater that then itself is leaking.
It's like a leaching, right?
Yeah.
It's
Okay.
so it's
Okay.
like drains into the catch basin that
Yeah,
has a leaching
okay.
field, and so there's nitrogen, there's nutrients that's getting into the groundwater from our stormwater systems, and I guess I assume, I don't know, that nitrate is less concentrated than some of our, more residential septic sort of
Right.
issues. But I was curious to hear your thoughts on that
Yeah,
approach.
Yeah, and you're right, it would be diluted because you lower concentration. But what we know with our goals, it's not necessarily concentration, it's mass, right? So if you can quantify that here is the mass that's coming out of that environment, then if that is a high mass driver, that could be a place to target. So I think the first question would be, again, characterizing how much nitrogen mass is going out of there per storm, per year, something like that. And is that a significant source enough to target that for a treatment? Could you put a PRB, like an injection PRB, near that? We would want to offset that, because the last thing you'd want to do is to get EVO going into your sewer, which then would be transferred somewhere else. But yeah, we think about that. I mean, also depending on the depth. I mean, if those catch basins, or if you know where they are, that actually could be a place where maybe some mulch or a trench. But an injection could be, it depends on how deep you need to get. One of the advantages of injection versus like mulch is depth. If you need to be deeper than the water table, where like being able to excavate into the water table is a challenge, right? You may need to do water. So in those cases, if you need to be deeper than the water table, injection could be something to at least evaluate. And even if you had a quick scenario and like, all right, here's how big that catchment area is. We maybe think it's 40 feet. We think this depth. Yeah, let me know. I can probably put together kind of a plus or minus cost estimate, just something like that. Because sometimes, as I said, you kind of think about this stuff qualitatively, but until you actually start running the numbers and come up with a cost, you're like, is it cost effective? Is it a good option? Is it not? And then you but then you also think about implementation as well. So, yeah, no, it could be, but is the mass flux coming from that concerning enough, or are dollars meant better spent first for characterization and then for treatment elsewhere? But you have to kind of think about that. And
Interesting. Thank you.
You don't have to ask a question.
Oh, I've got a couple, mostly involving costs. You're talking about maybe perhaps off in the future moving to residential. Any idea what the permitting costs would be for any of your projects, from New Orleans project down to something on a residential lot? I mean,
so it'll be interesting. So I can clearly speak to what the permitting costs would be for what the demonstration test would be.
right.
So EVO injection is done all over the country, all over Massachusetts, but in Massachusetts it's mostly done under the MCP for treating chlorinated solvent sites, the Massachusetts
Yes, sure.
Contingency Plan. The Orleans project was the first UIC permit that Mass DEP issued for EVO. So it was new to them at that point. So we really had to walk them through, because they handle all injection processes. So I was involved in working with Mass DEP, walked them through. They got very comfortable with that. So when we did the Falmouth one, that was the second one they ever did. I called it the same person. I said, it's almost the same thing, almost same length. And he said, okay, well, we need this, and this. We put together a brief technical narrative, what we were going to do, what our sampling plan was going to be, what we were going to inject, and kind of limited hours. And so I'd say on the order of probably $2,000 to $4,000 tops for the company.
Oh, good. I was figuring it was going to be under 10. So it's
Yeah,
in terms of
yeah,
the
yeah.
overall capital cost.
They waive there's a permitting fee to actually apply for that, but it's a few $100s typically.
Yep.
And so far they've waived them for all the PRB, the pilots, because they were municipal projects. So they knew the town was the actual funding agency, so they waived them, but it's only a few $100s. So yeah, I would say probably less than $5,000
Yeah,
easy. And that'll be an important question for when I talk to DEP next week, knowing that more of these could be coming. They should brace themselves, but I think the review time and their understanding and what they're looking for, they can probably streamline for users like all of us. So, provide this, and this, and that'll also cut down on the costs for the permitting eventually.
And it won't be linear with length.
No,
I mean,
for the
it'll be
permit,
for per application. So
Yeah.
it would be the same permitting effort if you wanted to put a 100-foot PRB in here or a 2,000-foot PRB a mile that way.
Right.
Because you're just permitting for that injection process.
And if you look at the cost per pound of nitrogen removed, which of course is the I think, I'm a little biased, is the most important metric.
Absolutely.
So if you levelize the costs, I wonder how it plays out, because the best local data I've got is the Little Pond project here in Falmouth.
Okay.
And it costs about $2,000 a pound.
Okay.
That's the initial capital cost. It was about $20,000 per residence. But once that's done, at least from my standpoint, it's a lifetime.
It's true.
That system, I mean, I don't know what the decay curve for municipal sewer system looks like, but it's got to be a pretty shallow curve, where this is going to presumably require redoing, maybe on a scale of a decade.
Say 10 years. Yeah, that's a good scale.
Yeah, so I would love to see the sensitivity analysis be done on a levelized basis and figure in the lifetime, because, I mean, there are finite costs obviously involved with sewers and operation and maintenance costs too, that wouldn't come into play here. Once this is in place, you don't really have any maintenance costs, so it would be,
Right. This you inject it.
yeah, and walk
you-
away.
You walk away, except for whatever monitoring the DEP
Right.
want to do. You'll have a couple monitoring wells.
Yeah.
And I think once they get more comfortable with this, for the demonstration tests, we were sampling them quarterly. We wanted to see kind of what are those
Sure.
timeframes. But I think once a year may not be out of the question. Once they're just going to eventually want to see some level of demonstration, because if you're using it for credit, they're going to want to know that
That it's
you're going to
working.
get that. So there may be higher frequency, maybe that first year, maybe you got to do 4 quarters, and then maybe annual after that. That's all stuff that DEP is going to have to get comfortable with. But yeah, I mean, some of the question is, there are some communities and some neighborhoods that are very accessible for connecting.
Right,
Other
yeah.
ones are further away.
Sure.
And so PRB is definitely not is not going to be the tool for every watershed, every area. But for certain places, I think it is a viable tool. And if you're looking at $2,000 per nitrogen removed, even if you do it once a decade, and if our costs are closer to $300-400, yeah, you can do that for 50 years. And then who knows? Does advanced treatment get better over time? Or there's a lot of kind of temporal questions of that as well. So,
Paul, I'm enjoying this talk immensely, but you're way over the time budget that you told Kristen.
I apologize.
So, and I'm going to go through the rest of the committee.
okay,
So please try to make the answers as
Sure.
quick as you can.
okay.
I just have a quick question. What are the actual concentrations comparison between Orleans and the 2 concentrations in Falmouth of the EVO?
10 milligrams per liter.
Orleans ranged generally from like 5 to 30, and Falmouth was probably 5 to 25. I mean,
Okay.
different wells, different vertical intervals.
So there wasn't a huge, that was the high, okay.
Yeah, their highs were similar. Their averages were similar. There's just different vertical variability, things like that. So.
Great wealth of information, thank you. One thing I was wondering about, you talked about in your cost analysis, the actual cost of the material, pumping it in the ground, drilling the holes, et cetera. How about the cost of site evaluation? The pre-engineering and analysis you have to do to determine the ground flow, water flow rate, the nitrogen concentrations, the depth that you have to then drill. It would seem to me there's a lot of pre-engineering cost involved in analyzing the site before you inject. What is that order of
I
magnitude?
don't remember off the top of my head. I know Kristen and I put together kind of a rough number, kind of plus or minus, a few months ago for kind of thinking about a site and how many wells, and so, yeah, I would have those, I just don't have off the top of my head. But yeah, you're right. I mean, and the more you do, the more effective your PRB could be, or your placement, so.
Right, but the cost of doing that has got to be part of the cost of the project, so the analysis can be pretty extensive, especially as you noted, there's such variability even along the few hundred
Yeah.
foot length that you've installed that, gee, the groundwater flow here is different, the nitrogen here is different, it varies so much with the depth, so trying to optimize the system design, you need a lot of pre-data collection and
you would need
analysis.
more pre-data, yeah.
Yeah, which I would imagine would be significant. You know, one of the things, and I'll stop with this question, is when you talk to DEP, how they would determine any potential credit toward a TMDL that they would allow to this is something we've wrestled with on a whole bunch of other things as we go, and that's going to be a very interesting discussion you will have, and I think it'll be great for us to get some feedback on that once you've had that and can put it in a concise little report.
Yeah, I mean, some of the investigation costs, it's either drilling some holes, collecting some groundwater samples. Nitrate analysis is really cheap. So it becomes a little bit more just the human time. The drilling's not that much, so just as long as you're not thinking about going down 100 feet, which Orleans did do investigations down to 100 feet near the landfill there. But for like the Sherwood Drive site, a lot of our investigation was shallower than 40 feet. So to do that, you can in a single day, you can probably install maybe 6 or 8 monitoring wells in a day. So you could have, maybe 2 days of drilling in the field, and then just put whatever wells you want to put in, sample them, and then you'll know. Maybe you sample them 2 quarters just to get seasonal effects. So yes, it is an important piece, but it would not necessarily have to be a major cost.
So I just pulled up the cost estimate that you and Jim Begley had pulled together. It was for a 1,500-foot PRB for the site evaluation, and it was about $120,000 was the estimate. And there's a bunch of different itemized in there, which we don't need to go into, but that's the rough cost.
120,000.
Mm-hmm.
Okay, thank you.
But on a $1 million project, 1,500 foot would probably be $1 million PRB. That's
So 10%-ish.
maybe,
Well,
yeah.
Ken?
I'm just wondering if you measured, and you've injected this EVO and it's going into the interstices of the sediment, whether you were able to measure any changes in the flow rates in response to the presence of that EVO.
We have not done that on any of the Cape Cod PRBs that I'm aware of, but there was another PRB project that I was involved in Pennsylvania about 1.5 years ago, and the consultant did do slug testing in the PRB and immediately downgraded into the PRB. And any changes that they saw were deemed, their project geologist said, this is all within the range of, I think there was one well that was like almost identical, and maybe one well, the K value in the slug test, the hydraulic conductivity was reduced by a factor of like 2.2. But when you're doing slug tests, when hydraulic conductivity is the order of magnitude parameter, a change of 2x bigger, 2x smaller is kind of within what you'd expect for slug testing. And they had a handful of wells, so they could take like an average of that.
Any quick questions from the audience that are amenable to quick answers? Thank you very much, Paul.
Right, thank you, Reverend.
The next item is walking up to the podium to tell us about the potential elements of the Wacoit Bay Eel Pond watershed. Kristen.
Kristen Rapton, Science Wares. So this follows the series that we've been doing for some of the potential elements that could be included for the watershed permit process. This time we're going to start looking at Wacoit Bay. Because Wacoit Bay, because of its size and complexity, in the MEP there's actually 3 different sentinel stations for Wacoit Bay. There's Sentinel at Eel River, one at Childs River, and one in the main basin. So we're going to actually look at the 3 areas independently. So today we're only looking at Eel River. Eel River is actually made up of 3, it's in the MEP it's Eel Pond, 3 sub-embayments. So Eel Pond West, Eel Pond East, and Eel Pond South. So those are the 3 that are kind of outlined in purple. This is the entirety of the Wacoit Bay watershed, all of the sub-embayments and sub-watersheds within it. These are the loading values from the MEP. Again, follows the same format we've been talking about. Because we're only talking about Eel Pond, that's what's highlighted in yellow. So you have your threshold load, the present load, the MEP for Wacoit is 2013, and your build-out loads. This final column over here, this is the result of the analysis that GHD did for determining the allocation of what proportion of each sub-embayment is Falmouth's responsibility. So all 3 of the Eel Pond sub-embayments are pretty much wholly Falmouth's problem. When you take those loading values and translate it into the mass of nitrogen that needs to be removed per year, which is kind of how the town has been doing its assessments, looking at the different sub-embayments for the present load and build-out loads. Individual sub-embayments are on the yellow, and then the total for Eel Pond, again, this is Falmouth's portion, which is pretty much 100%. The present loading for MEP is about 3,200 kilograms per year. The Cape Cod Commission, on their watershed planning tool, they don't have it broken down by the individual sub-embayments. They have Eel Pond all lumped together, and they're indicating that there's a removal requirement of almost 5,200 kilograms now for present loading conditions. This is the table that was included in the 2019 CWMP update. This is the most recent formalized plan of how the town intends to address nitrogen reductions. So your stormwater and fertilizer BMPs, your shellfish. As I've said in previous presentations, the town does not consider the denitrification to be a credit that the state is going to allow, so that kind of gets removed from the calculations, and the estimates for sewering. This table was completed ahead of the GHD allocation. There's 1% in Eel Pond West, that's part of Sandwich, but they will probably apply for a de minimis load exemption, so I wouldn't expect any contributions for nitrogen reduction coming from them. Again, to review, this is the planned and projected sewer areas of what the town is already considering when it started evaluating discharge site options. These pinkish peachish colors, those are the projected future sewer areas. So this is the area we're talking about: Eel Pond West, Eel Pond East, and Eel Pond South. From some of the other presentations I did recently, this is just the visual of what the 2-foot predicted sea level rise, and in turn what the response to groundwater elevation looks like. So after we talked about depth to groundwater for the state requirements, and John Waterbury updated and said basically for Falmouth it's a 10-foot requirement for septic, I asked the Cape Cod Commission to update their layers. So this is now the surface distance to groundwater between 0 and 10 feet instead of the 8 foot that we've been looking at. So the darker purple is what is attributed with sea level rise, so what would be inundated by actual seawater. And the pink areas, those are the areas where you would see groundwater, depth to groundwater between 0 and 10 feet. So areas that might be at highest risk for violating Title V compliance. Similarly, tying in the evaluation I did of lot size and potential lots that might not be suitable to fit an IA system on there. This is what that map looks like in the upper, just south of Route 28. Again, highlighting why we're looking at sewering for Seacoast shores and Antler shores for that area.
So basically, all those lots that have either yellow or orange would not be suitable.
Could be a challenge for siting an IA on that property based on the hardscapes that are there.
But they are in the proposed sewer area.
Yes.
They are, but.
Right.
Just.
Right, I'm just tying in all these other things
Partly
that
for
I
that
stand up
reason,
here and talk about.
Right. Exactly.
All right, so we're gonna go through the same scenarios that we do for the other watersheds, regardless of how inherently applicable they are. But it's the elements that we've been talking about as a committee going through. So the first one being the IA 300-foot boundary. So for Eel Pond, this is what it would look like. We also have shellfish on here, regardless of people's feelings on whether they like shellfish or not. The yellow polygons are what was identified by Chuck and Marine and Environmental Services when they did their surveys. So if you look at the numbers, again, using the IA performance value at 10 milligrams per liter and based on the water use for those parcels, and how it works out between the present load and the build-out load removal, what you're getting in each of the different sub-embayments. By using the 300-foot boundary, you are coming up short with the present load for the TMDL and not even close for build-out. And just a caveat reminder that the build-out values done for this assessment are build-out related to the identified parcels. So if these parcels don't get built to their full potential, the implementation won't have any additional effect. So if you're counting on these implementing here for build-out and what gets built out is in the upper portion of the watershed, you're not going to have any effect on build-out. So this is it broken down by percent of reaching the actual TMDL target. So you can see everything except for Eel Pond South, which really is only like a dozen houses right at the bottom of Seacoast Shores. Nothing meets the requirement. So if we look at applying the planned sewer area, so this would be Antler Shores and the southern portion of Seacoast Shores. Only the southern portion because that's the only part that falls within the Eel Pond subwatershed. This falls within Childs River. And again, Shellfish. So looking at the numbers the same way, again, if we're sewering and discharging outside of the watershed. In this scenario, we meet the TMDL. I have this number in parentheses here. This is taking out any nitrogen credit for shellfish uptake. So you can see what that effect is. So we're looking at a little over 3,200 for present load removal. So we get kind of close even without shellfish. Build out, again, it's specifically related to those parcels. This scenario does not address build out. And there's the breakdown by percent, so you can see what it looks like for each of the individual sub-embayments. So the final scenario would be what else could be done to get you closer to your build-out targets. So,
Kristen?
Yep.
When you think about build-out, do you assume that the build-out would occur on a sewered lot?
So
After it was built, it would be sewered?
So when I do build out, the Cape Cod Commission it's all based on what the land use code is for the individual parcels. Cape Cod Commission has the future projected water flows for those parcels, which would assume the full build out potential for what their land use code is. So it's based on those individual parcels, and it's tied to land use.
But, but what does it appear to you when you've been looking at the data? Are the vacant lots that could be built out?
Some of
Are
them,
they
yes.
50%, 80%, 2% in the?
I haven't done that kind of assessment on how many vacant lots there are. Again, because it's looking at, when I'm doing the numbers, I'm looking at this entire area, and what it's doing is pulling all of the data together for all 1,000 of those lots and saying, here's the sum of what the future water use would be for these lots. Whether it's a 3-bedroom that can expand to 4-bedroom or a vacant lot that then gets developed for residential. But that doesn't include anything for 40B.
Kristen, I'm assuming that south of Route 28, that whole area is almost totally built out.
Yeah.
That there is no
So
road
based
forth.
on how these numbers don't change a whole lot, I agree with you. Because this is what the future wastewater flow for these pink lots are. So there's some, according to the Cape Cod Commission, and that data is, I don't know when their last future projections were done, but some of that data is getting old as well. Not as old as MEP data. But, so that's something that should be considered when the actual plans begin to be formally developed of what's the updated land use for each of the watersheds. So back to the final scenario of what additional measures could be taken to achieve the build-out. If you think back to the parcel lot IA map I showed, this portion on the western side was also pretty spotted with the yellow and orange. So potential expansion of the planned sewer area to encompass that. Again, any proposed expansions to sewer is related to discharge capacity. So all of the discharge capacity evaluations have formally considered the pink areas, those areas that were on that map I presented earlier. Additional areas are subject beyond what was originally planned for.
So the dark blue, the septic improvement area, you're proposing putting IAs in there?
So I'm proposing something should be done with septic, be it IA or sewer, but if there's no capacity, then you can't do anything for sewer. So then that's all contingent on the outfall and discharge site, so we can't say publicly that that would be a sewer area, because we don't know.
When you did the, I'm trying to remember your maps, when you did the lot suitability analysis, does that purple area have lot suitability, adequate lot suitability?
So there are some in there, I don't have this section queued up, but that's another evaluation that would need to be done if this is the route you're going to try and achieve build-out. If you put growth controls such as any new construction, redevelopment has to put an IA in, you don't have to consider build-out or growth within the immediate plan. So that's something else that needs to be considered within there. But some of the areas that I highlighted for this exercise was the western part of the eastern part of the western peninsula in the watershed. And also there's a cluster of homes up here, north of 28, that are far enough from the sewer area that maybe IAs make sense there.
Kristen, the other thing which we made the unfortunate precedent of when a property is sewered, by right, they can upgrade to 4 bedrooms.
Mm-hmm.
And if you look at Seacoast Shores, I would guess the vast majority of those homes, those 1,000 homes, do not have 4 bedrooms at the moment. And so that becomes a huge extra potential discharge that we need to think about.
Right.
Very good point.
So running the numbers on these areas, again, the orange area I considered to be a sewer expansion area, so that would be full nitrogen reduction for those parcels. And the dark blue ones being a septic improvement area, so at least a removal to a performance level of 10 milligrams per liter. So I have that broken down. On this line, this is that southern septic improvement area, so if it's done with IAs, what your removal numbers would be versus if it's done with sewered. So you can see that under the build-out scenario, if you look at it as IAs, we don't get there. If it were to be sewered, you pretty much come close to achieving that build-out number. Again, these are just potential ideas that can get incorporated as the plans get developed. So something else to consider, that's how it breaks down for the removals by sub-embayment. What else can you do in the upper portion of the watershed, so north of Route 28? So that sub-embayment is highlighted in yellow. A lot of these parcels right here, that's the airport. This is part of the golf course. So you see the next biggest contribution would be from these homes up here. So what can you do? You could potentially do a PRB along Carriage Shop Road, because that pretty much runs perpendicular to that sub-embayment. But if you want a sooner gratification, you could think about along Route 28, because that also runs perpendicular to that particular sub-embayment and is closer to the actual surface water. So those are just some other ideas to toss out besides additional IA upgrade mandates.
What would, the groundwater flow is by definition parallel to the watershed boundaries at the boundaries, right? If the boundaries were drawn correctly,
Yes,
which
yes.
is a big if, but in
Right.
theory, they're there.
In theory, right.
So that a PRB completely across the watershed.
You should catch a
In
whole
theory, you
lot.
catch everything.
Yeah,
In theory.
So what's the disadvantage of putting it as far south as possible?
There's not. It's what Paul was saying. It's all about your site characterization because you don't know what depth you need to be at. So that's all, the preliminary characterization that would need to be done. It depends with Route 28. There's probably going to be a lot of other utilities running through there, including a sewer, and whether you have space to do injections in there. So again, site suitability.
so, Kristen, can you go back to your fourth slide, excuse me, I think it is, yeah. It says Municus River Upper Quashnet. The Municus River is the lower Quashnet, and that's repeated in several of the other tables.
This is specifically how it's identified in the MEP. So these come straight out of the MEP.
I've seen it before, and at least we're being consistently messed up.
Yes,
Okay.
and
Maybe water
I'm
flows
being
upstream.
consistent with the MEP, as hard as it is, and that's why I wrote Eel Pond and had to change everywhere I put Eel River in here.
Right,
Take that up with the late Bryan House.
right.
When is it next?
So, and if you could go to the sea level rise slide, why is Washburn's Island?
I'm not sure why that's completely under. I feel like that's a fluke in that landmass isn't in the Cape Cod Commission GIS layer properly.
Okay.
That's why I tried to cut it out of the image as much as I could.
Okay, yeah, because it didn't make sense to
But
me.
actually, that's extremely relevant, right? Because with sea level rise, that bar across there, which I've been on, is very low and is likely to not be there. So you get free inlet widening on a massive scale.
Right. Now, but the other reason for bringing this up is this is for a two-foot increase.
Right.
When is at the most liberal model out there, when can we expect a 2-foot rise in sea level?
50 years.
Yeah.
It was, I
And then a
think,
realistic estimate, though, is probably 100 years beyond that.
potentially.
Yeah, unless something
So,
catastrophic
But
happens.
that's why we're only looking at the 2-foot one, even though USGS also modeled 4 feet. So
Yeah.
this is the more,
But you don't see them moving their offices yet.
no.
And now some good news. If we use last year's shellfish nitrogen sequestration numbers, the numbers in all your charts for aquaculture basically are quadrupled, which helps meet some of these standards in a bunch of these cases because the Eel Pond South thing moves from 200 to 1,600.
So
1,655 kilograms.
all of that comes back to what the state gives credit for, and we go back to where the shellfish are and what kind of actual impact they have.
Right, and would that have any impact in the connecting water bodies? But I'm
Correct.
just saying, that's the good news, and last year, maybe a 1 in 10 year phenomenon. We don't know yet, but I just wanted to point out that maybe we can play some boundary.
And all those shellfish numbers were done very conservatively, because they were done to be attainable targets that the commercial guys could achieve to maintain their lease. So that's what the town expects them to bring in. Anything above that is additional. So for planning, you want to plan on your conservative end and be thankful when you get more than
But
that.
I'm just saying, this is prospective good news if
Yep.
we go back and do some remodeling.
This brings up a question I had. Why aren't the other, current shellfish beds in that?
Because they're up here
Right.
in a different watershed. We're not
Oh, you mean the
talking,
commercial ones?
Yeah.
Yeah,
because we can't really claim credit for the commercial guys because we have no control over measuring the uptake in their shellfish. So
I thought they were
when-
doing that.
When it's this partnership with the town lease, there's a subsample that gets sent in for nitrogen analysis to justify when we want credit for it. So nothing's been breached with the actual commercial guys on what that looks like for nitrogen credit.
But the people that we're funding, Tom, are commercial. I mean, they're making a living at it.
Oh, yeah.
They may be commercial and they're commercial / town subsidized as opposed to purely private. Is that a fair way of describing it? What I'm getting at is the people that are subsidized by the town now love it.
Well, yeah, they've got a really sweet deal.
Right, so why wouldn't these other commercial ones fall for the same deal?
They've got a very different setup, and I'm not sure they would sign up anyway.
They already have their leases. They
Yeah.
have their private leases that aren't managed by the town.
Yeah, and they can do whatever they want.
Right.
And related to that, you made a point that you cut off the red areas over on the right. No, stay on that slide, right there.
Here?
Because that's a different watershed.
Mm-hmm.
Because you knew this red area wouldn't benefit that upper
Correct.
watershed.
So right here, this
Because
blue
it's
line,
downstream of it.
right, that blue line shows you where the sub-embayment line is.
Right.
So this is part of Childs River over here.
Right, but I'm getting at something different. That was just a trick introduction.
Right.
The yellow oyster areas are way down near the mouth.
Mm-hmm.
So it seems to me you have to discount them some for the fact that
And that's
doesn't.
why I put it right here without shellfish,
Okay.
Yeah.
just to see what that looked like without the consideration for the uptake. In the current working scenario that the town has been working with. So you still are very, very close to meeting the MEP present load without the shellfish
Great.
included.
Thank you.
Yep. I listen to you when you make comments in other meetings.
Sometimes.
One last quick question. What's the time of travel between carriage shop and 28? I wonder, is it 7 or 8 years, maybe?
I don't know.
Yeah,
I haven't
well-
done any modeling for that, and that's
Well-
something I can do.
Well, it's
This
on a
was
bunch of the watershed maps. It'd be very easy to kind of interpolate, I think.
Probably.
I'm just
My
guessing.
guess would be probably a decade.
Yeah.
Any other question? Any questions from?
Not a question, but a comment. I think, one of the things that I look at the analysis and the PRB presentation that was just made and some of the other things we've talked about, in my experience, the best way to control a pollutant is grab it at the source of emission. A PRB, as an example, I'm not picking on them, but PRB, as an example, is looking to catch it after the fact, after it has been widely dispersed. On a cost to do that, it can get prohibitive very quickly, and it just leads to, my feeling is, if we're not gonna catch it with an IA right where it comes out of the house, or with a sewer, which is probably the best for longevity, we're really chasing a whole bunch of smoke that's out in the atmosphere. It's gonna be very difficult to, I think, get DEP to buy off on any kind of significant credit towards TMDL by putting a PRB across something.
So what
It
that
can be
does
extremely
is-
effective, the science shows it, the practical applications show significant reduction, but to get DEP to marry a number to that, gonna be very difficult. Tom's whole shellfish thing has shown incredible numbers of actual nitrogen capture, but how much do they give us credit for? And the whole idea is, and I know Steve isn't that keen on shellfish, but a pound of nitrogen out of that water is a pound of nitrogen out of that water. And boy, it's real, and it's gotta help that water, even though maybe mostly at the
Right, at the
beginning
southern
of the estuary,
portion.
near the discharge to the ocean, and not so much at the far reaches, but boy, it's still a pound of nitrogen out of there.
Right.
But if you're putting a PRB, let's say along 28, you're catching legacy plume from the upper watershed that wouldn't necessarily be otherwise caught. If mandates for IAs were put in for the upper watershed, you're now trying to catch 10 years, so you're saving 10 years of legacy plume from,
Could be.
still could be,
Yeah.
from
Right.
continuing to degrade the estuary.
And
You're
the-
also capturing nitrogen from all sources, fertilizer, precipitation.
Right.
The other thing to think about too is I was trying to get his talk back to, and again, we're never gonna be able to do it again for $2,000 per pound of nitrogen, like, which is what a little pond represents. Everything's gonna be at least 50% above that. I can guarantee probably twice that number. But that really has to be our key metric when we're assessing how things work out, is what does it cost to pull a pound of nitrogen out? And if you're talking about IAs or sewering 1,500 homes, for example, what does it cost when you take the time considerations and everything into account? What's the most effective economic approach to capturing that stuff that we want to capture?
Well, I hope that Paul will get back to us after he meets with DEP and tell us how many decades they are estimating before they give us an answer on
Well, that gets
what
to-
credit we might get.
Yeah. Thank you.
Thank you.
Kristen.
Thank you, Chris.
Well, can I ask one last question, a very quick one? Don't go away.
Oh.
Okay, this is great. This is like the second or third one of these, maybe fourth that we've heard. What's the next step?
That's,
How do we refine this to the point where it's submissible?
so what Steve Rafferty's view is, these are all the pieces that are going to help the town come up with the scope of what they need to consider for each of the watershed plans when they start to put that together, to formalize that process. So whether, and it's also looking at what kind of costs might need to be included for that planning purpose. That's my understanding of his vision for this.
When they formulate the plan.
The town, whoever
Who's
they
they?
contract, right,
Speaking,
Oh,
Here comes
hey.
they.
coming to the podium.
That was not the goal. Amy Lowell, wastewater superintendent. Kristen, on behalf of the town, submitted our notices of intent to prepare watershed permits for all of the estuaries, and we grouped them into 4 groups, and we said what our schedule was going to be. So in order to submit those plans, we, the town, are going to have to draft. We're going to need to request funding. I believe we'll start requesting funding as soon as this fall. We can talk more about that in the coming months. And we'll look at funding for plans, which would then feed into watershed permit applications. What Kristen is doing is giving us a head start on those plans, and it's terrific.
Any other questions? John?
Kristen, can I leave one thought with the committee to think about? What Kristen has presented to us is what we would think of as a total solution for the watershed plans. We know that we're potentially not going to get to Wacoit Bay for a number of years. And we've had, the Wacoit people have been very interested in us coming up with some sort of an interim solution that would help and make a real impact on Wacoit Bay. And one of the things which we might consider is that 300-foot boundary with IAs. And you not only have to do that in Wacoit Bay proper, but you have to do it in the Eel River and around Cmte, because they're all tidally interconnected. So one of the things we might think of as a partial solution for the next 25 years is that we mandate under a certain number of conditions, sale of property and failure of systems and several other things, that IAs that meet the standard of 10 get installed within that 300-foot boundary, so that we begin to make a real impact on the health of Wacoit Bay.
Amy?
Just for discussion, I think we might want to think about, rather than targeting areas which we plan to sewer, I know it is going to be a long time before we get there, but rather than targeting areas we plan to sewer, maybe we identify the area that we think ultimately we're going to want IAs, the area that we're not going to sewer, and we identify that sooner and get that started sooner. It's obviously, that's not an official plan right now, but it's something I've been thinking about, that we believe that in many of the watersheds, there will be an additional north of 28 less densely developed area that will require IAs, even with sewering in the lower watershed, and we could identify that sooner and get it started sooner, even though it seems a little backwards because it's further from the water. But that way we're not imposing an IA solution on the properties and then 15, 20 years later having them replace those. Just food for thought.
So, Kristen, did you just do items 2 and 3, or just item 2?
Just item 2.
So go ahead with 3.
All right, so item 3 is just the update on the 604B application. I've got a rough draft that Tom and Steve Rafferty have been looking at. The select board Monday night approved the application on the consent agenda, so I'll be working with Amy in the next week or so to get some town sign off on that to be submitted, and that's where that's at.
The deadline is May 5th?
May 8th.
May 8th.
May 8th. So our next meeting is on the deadline, and I hope not to be submitting it at midnight that night. So it will probably get submitted prior to the next meeting.
Any other questions? Okay, thank you. Reports of members and staff. Tom
Yeah.
was bumped last time,
Yeah.
and he promises that this will take 5 minutes plus 5 minutes for
5
questions.
minutes, yeah, I think it's gonna be pretty quick. And then I've got a topic for discussion that I don't necessarily want to lead the discussion, but I want to get the committee thinking about very quickly. Steve Rafferty, not Steve Layton, asked me, I think he's the one that found out this report now. I'm not sure which.
Do you need help?
I always need help, but let's see what we can do here.
Good.
And,
Arrows or click?
and I advance with the mouse here. Wow. Great. Anyway, there's something that I really didn't know about until recently, and that's LNAP, which is the Long Island Nitrogen Action Program, I think. And I will tell you right now, from my experience the last really 7 or 8 years, is New York State and Long Island in particular is way behind us in dealing with nitrogen thing. But apparently they commissioned this study, and Steve Rafferty wanted me to look at it in the context of the inlet widening in Bourne's Pond that I've been sort of peripherally involved with for several years. They didn't call it inlet widening. They called it embayment water exchange study because they were looking at something well beyond that. And this was mostly just a paper exercise. And for modeling purposes, they really were only looking at change effects on residence time. And they came up with this categorization of water bodies. They didn't call them coastal embayments. And I don't see any difference between a harbor with a sand spit and a coastal lagoon, except maybe there's a slightly deeper channel. They didn't get any details in the report in there. But those two to me are basically the same thing, and they're very typical coastal ponds that we have here in Falmouth. And again, in their case, they're going to remove some of the sand spit that was impeding circulation or back and forth flow. Tidal stream, the thing that comes to mind here in Falmouth is Herring Brook in North Falmouth. It's just a narrow stream that happens to open directly into salt water rather than into some freshwater body. And in our case here, and probably these other cases, they pretty much drain every tidal cycle, or twice a day, really. And then they have the shallow open harbor. Our equivalent, I think, would be Megansett Harbor. Again, the vast majority of the embayments we have here in Falmouth fall in their harbor with sand spit or coastal lagoon. Now, the key thing here, and I don't want to go into any details, you can look at the finding, but basically, and they considered a lot of different things. They considered active pumping, they considered tidal force pumping, using pipes to connect different parts of the embayments, either to the larger outside, and they even considered tide gates, which would let water in at certain times and then let it drain out at other times. And their conclusions in all of these, and you can sit and read the second column over here under findings, but basically it had little, if any, effect on water circulation or the exchange of water in there. So this whole study really didn't find much of anything out at all. Their conclusion was almost all of their embayments were so large that it would be too expensive to somehow actively exchange water. And to me, it was kind of an exercise in whatever, but some consultant got a bunch of money to come up with this.
You better hurry up and tell us why we want to be listening to it then.
I'm being very quick, but I'm going to get to the good part now. The good part of this, and I suggest anybody else that's interested in this stuff, they came up with a very, very complete set of evaluation criteria. This is just one page of their evaluation criteria. The only complaint I have here is their shellfish metrics, which they want to use. They look only, in their criteria, they would look only at larval shellfish. And of course, I'm much more interested in what the adult shellfish are doing. And I don't know why they were dumped from the system, but what degree would larval shellfish survive and settle out in there? And then the permitting and documentation complexity metrics they call out as a big stumbling block for these projects. And then here's the other list of metrics. And what I found particularly valuable when you want to sit down and pick these things apart. Let me get to this. This is, I promise, the last slide. Here is when they put all of their evaluation metrics into a spreadsheet approach to the different categories across the top, and then broke it out into subsets. Up there, in the case of the open harbor, did you put in a pipeline? Did you do what they call environmental dredging? Is not channel dredging. It's dredging just to increase water flow. It's not for maritime traffic or anything like that. And they ran across the different things, as you can see, subsets there. But I found it very useful to look through and see all of the different things that they were considering. So that, to me, was the high point of the report, was just to look at what they had set aside as their metrics. And that's my brief
You did it.
report. Questions, anything about this?
Any questions from the committee?
No, I just,
There's one from the audience.
oh, yes.
Did they provide any of the baseline criteria that we talked at previous meetings about before they went about suggesting changes? The chemistry, what analysis they would get?
No, this was, the best I could tell, was a purely paper exercise, and their main criteria was what they call residence time. The flip side of it was called flushing rate. In other words, residence time, once a water particle is in the abatement, how long does it tend to stay there? Conversely, so yeah, it was, they didn't really look. They said these are things you should consider, but for this point in this report, they didn't. It's supposed to be a handbook. It was released in this past December. Now, something else I want the committee mainly to think about, and I think all of you have gotten the announcement about the Cape Coastal Conference that's coming up in mid-June. And I've been having some interactions, and Kristen came here a couple of weeks ago and told us about it and wanted our input, and they've now announced the theme is, or the title of the whole thing is Collaborating for Solutions, Practical Sessions to Achieve Watershed Plans, Case Studies that Apply Traditional and Alternative Methods to Reduce Nitrogen and Improve Water Quality. And I've got another meeting with her on Friday, and I I'm asking for an endorsement from the committee on this. I'm pushing her hard to have the regulators be at this meeting and participate in a panel discussion where the regulators would be put on the spot and say, what are the criteria that are important to you in terms of whether or not we're meeting their goals and our goals? Does that sound like a
Sounds
reasonable?
fantastic.
Does that sound like a reasonable? I'm trying to move it that way.
I would say it sounds like a great idea, and I feel like it's something we talked to her about when she was here. However, whether or not she can get DEP to show up is clearly out of our control.
I just want to,
Yeah.
when I talk to her again on Friday, we've been playing phone tag all week, and like I said, I did want to say to her confidently that, I mean, it's just a sense of the meeting. I'm not calling for a vote or anything, but is it something we should pursue?
Does anybody not endorse this?
No,
There's your
okay,
answer.
but, all right, thank you.
By the way, there, years and years ago, the town had John Ramsey or someone, Amy may know the details better, do an analysis of all our estuaries for inlet widening. And they came up with Bourne's Pond as being the
SMAS did that.
SMAS, okay.
Well, and Ramsey was part of that.
Yeah.
John Ramsey.
Right, they probably
He was
subcontracted.
subcontracted.
Yeah. We paid UMass and Ramsey did the work, right? And, I mean, that was serious professionals really analyzing
Right.
our estuaries.
Right.
And so we have those answers.
Well, we have, that's why we've, after many years, we're finally going forward with the Bourne's Pond.
With the Bourne's Pond, right?
Project. When I came on board, I think it was the spring of 2017, Virginia Valilla asked me at the time, would I sort of be the point person on the Bourne's Pond thing, along with a couple other loose ends? And I said yes, and if I remember correctly, we had to get permits from 17 agencies, from the Corps of Engineers all the way down to Falmouth Conservation Commission to do it. And that took a very, very, very long time. And then we've had a couple of bumps, but the money was set aside 7 years, sometime, very long time ago.
2014.
Yeah, 2014, 10 years ago.
10 years.
10 years ago, the money was set aside for this project. And this fall, we can't call it a groundbreaking, we'll call it a bar breaking. When they go in and pull the first additional sand, they're going to, people are familiar with it, they're going to widen the inlet from 50 feet to 90 feet.
Right, we know that.
Yeah, so.
You're all set, right?
I think so, yes,
I'm
thank
going to
you.
go ahead with reports of members and staff, this time from right to left. Ken?
Nothing.
Ed?
Nothing.
Nothing.
No.
The minutes of the prior meeting.
No changes, they look good.
Steve found a couple of typos, but I don't
Right,
know.
I took care of those two
Yeah.
very, very minor typos.
Okay,
Do I have a motion?
I move we accept as issued.
I'll second that.
All in favor?
Aye.
Okay. Who likes moving to adjourn?
You want to?
You're not having fun?
I'm not sure the chair can do that.
No, you,
Sure you can.
maybe in a fit of pique.
Oh, all right. I move that we adjourn. Is there a second?
Second?
Yes.
All in favor?
Yeah.
Okay, thank you.
All right, good.